And see, and now we had a short day, and now we're only going to do like 40 minutes. All right, and then not to mention, I might have some technical glitches. So yeah.
Can you?
Oh yeah, you have a palm tree in your window.
Yeah. Wait, hold on. I need to find a better.
Well, now we just see the wall.
Why does it work with my window but on my wall?
Because it wants to make it look like your house is on the beach.
Well.
So just sit in front of a big window.
This is confusing. Well.
How do you do that?
There you go.
Wait, what did I miss? How did you do that? The camera.
Wasting time.
I'm sorry. I'll stop it there.
Okay.
I mean, I went and got a drink, so.
It's just water or tea, correct?
Yes.
All right, so let's get back to some math. So we talked about, when we left off yesterday, we talked about uniform sample space. Now, if we were looking at this example, we have a numbers 1 through 25, and so they have a uniform sample space. So 1 showing up once, 2 shows up once, 3 shows up once, and so on. So I want to know, what is the following probability that the event A, that an even number is drawn? So I want to know what P of A is. So if we define A, that's the numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So how many numbers is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the size of A is 12. The size of our sample space is how many?
25.
25.
Michaela messaged me back. She says, it's been a rough time.
Okay.
She said.
I just want to make sure she's alive. I'll try to email her later. So 12 out of 25. And let me see if the book changed that to an actual decimal number.
Do you have to write it as a fraction, or can you do like a 12:25, like a ratio, or?
So technically when we talked about ratios, you could do like 12:25.
Mm-hmm.
But this will get confusing when we start talking about odds.
Okay.
So you would want to keep it as 12 out of 25 or as the decimal notation.
Okay.
Or the percent notation. And I'm going to see what the book likes to do. I think fractions are what they like to do. Yeah, fractions. They keep it as fractions.
Okay.
What about B? What's the probability of B happening? A number less than 10 and greater than 20. So we're looking at the optimal word here, and, right? If I go through all of these numbers,
that's a 0.
Right. 1 is less than 10, but it's not greater than 20. 2 is less than 10, but not greater than 20. And then we do that all the way through. So the only numbers less than 10 would be 1 through 9, but they don't satisfy that. And if I look at the numbers greater than 20, they're not less than 10. So the way B happens is 0 ways. So the probability of B is 0 out of 25, or 0, right?
I agree.
What about the event that a number less than 26 is drawn?
100%.
That's right. So we could say it's 1, or 25 out of 25, or 100%. What about D? A prime number is drawn. So if we look at D, if we look at all the primes, that's going to be 2, 3, 5, 7, 11, 13, 17,
19.
19, 23.
Uh-huh. I think that's it.
So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So the size of D is 9. So the probability of D is 9 out of 25. All right. The probability that E is a number that's both even and prime.
There's only one.
That's right. So that would be, which is 2, 1 out of 25. I don't know if y'all know this joke. This is the joke that my advisor thought was the funniest thing. All the prime numbers are odd except for 2, which makes him really odd. He like laughed for 5 minutes when he told me that joke. He thought it was the funniest thing. So there's Michaela. Yeah. All right, so any event that has no outcomes is considered impossible and always has probability 0. And if the word and was replaced by or, then we would say B is no longer the empty set. And so these are such a weird, that's not supposed to be there. So this is the same thing as the saying B is empty. And then if we say the ratio of B is the size of the empty set over S, which is the same thing as 0 over S. And of course, probability of having a 1. So that was like event C, where we had numbers less than 26 drawn. That is 13. And like I said last time, probability of any event is always going to be between 0 and 1. So if we end up getting a probability that's negative, we did something wrong. If we got a probability that's bigger than 1 or bigger than 100%, we did something wrong. So, and then the probability of an event is equal to the sum of the probabilities of disjoint events whose union is the event. So what does that mean? So let's look at this. An ordinary deck of playing cards consists of 4 suits: spades, hearts, diamonds, and clubs. There are 13 cards in each suit. Spades and clubs are black, hearts and diamonds are red. There's 13 cards in each suit, including the ace, 2, 3, 4, 5, 6, 7, 8, 9, and then the face cards, king, queen, and jack. Does that all sound familiar? So we all know what I'm talking about. Does anybody not know what I'm talking about? I will take your silence as we're good. All right, so if we draw a card from an ordinary deck of playing cards, find the probability that the card is an ace. So if I look at the aces in my deck, how many aces are in a deck?
4.
4.
So
So that
4
would
out
be
of 52.
4 out of 52. Now I would want to know, what is the probability of me drawing an ace or a queen?
8 out of 52.
Right, because you would have taken the probability of an ace, which is 4 out of 52, and then the probability of a queen, which is 4 out of 52. And by this being an or here, we would add them.
When you're doing probability, do you simplify the fraction or just leave it?
So this, you could read it as 8 over 52. Usually you would like it to see at 8 out of 52 because that gives you the, it gives you context of what it actually means. But the book, he does simplify these to be 1 out of 13 and 2 out of 13. So when y'all are doing the homework problems and y'all are looking up answers in the back of the book, they do write them in most reduced form. And as a teacher, you will have to make a decision whether or not you want these probabilities to be in the complete reduced form or you leave them as such. And it also will be important that when you're preparing them for standardized testings, that you know that you point out to them what could possibly be the answers that they should be looking for. To know that 4/52 is the same as 1/13. All right. So that makes sense? And so these would have disjoint event. So since we may not have the set theory background, so like if we were saying, if we're looking at the event of all the ace cards and all the queen cards. So we have the ace of diamonds, clubs. That's a pretty nice club. Hearts and spade, right? And the same thing in here. The queen of diamonds. That's not a diamond. Queen of clubs. Queen of hearts. And queen of spades. So we'll put a Q, 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 spade. Ace, 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 ace. There is no card that's an ace and a queen at the same time, so there is nothing in here. Nothing. It's empty. So that would mean that these would be completely disjoint. Now, if there was a card in here that would say, like if we changed it to a 3 or a heart, there would be a card that's both a 3 and a heart at the same time. Does it make sense? So that,
Are you supposed to draw
uh,
that?
most likely not.
Okay.
But this is a picture that you could do when you're showing these things and describing disjoint versus not disjoint. So we could look at this as a sum score. So if I look at the first dice and the second die, and so 1 plus a 1 is a 2. A 2 plus a 2 is a 4. A 1 and a 3 would give me a 4. So I have 1, 2, 3, 4, 5, 6, 7, 6 by a 6, which is 36 outcomes. Now, why do we say 36 and not 10?
Because it's a grid. You
It's a
multiply
grid,
by-
true, right? But in this case, by labeling these things like a first die and a second die, and this is where a lot of students get confused. Let me go get 2 different color die real quick. I have those. Oof.
Even if it wasn't 36, it wouldn't be 10. It would be like 12.
Brown and orange. Okay. So the brown was my first die and my orange is my second die. That they're counting of 6 on the first die and say a 1 on the second die is definitely different than say rolling a 1 on this die and then a 6 on that die. So they're going to be different. But the way that say a 7 can happen definitely has a higher chance of happening, right?
Is this the same thing as using 6 exclamation point on your calculator?
There's going to be a relationship to that.
Okay.
But that's when we start talking about combinations of things and then figuring out the probability of what is the combination of that happening. But yes, that is going to be related. Okay, so if I look at that, so 36 total outcomes, what is the probability that a 7 would be rolled?
6 out of 36.
So 1, 2, 3, 4, 5, 6. Or 1/6 of the time. What is the probability that a 3 is rolled on the first die? So the brown was my first die and the orange was my second die. I don't care about what's happening on the orange, right? Would it matter?
No.
Nope, it doesn't matter. So in this case, I could say that I'm looking at the sum square, it just being a 6 would be 1/6 of the time. This one actually worked. It's not in the book. Look at that. All right. Does that make sense?
Yes.
Cool. All right, let's look at mutually exclusive events. So far the things that we've been looking at were mutually exclusive. And by being mutually exclusive means that they have no common elements, or they have no common elements, or that their intersection is equal to the empty set. So if I was to look at A and B, this guy had stuff in it, B has stuff in it, but A and B have nothing that are shared together. So that would mean that they are mutually exclusive or that they are disjoint. So this also means that if I took the probability of event A happening or event B happening, this would be equal to the probability of A happening plus the probability of B happening. So for those of us who took 103, what was the property that we talked about before in this case? This is slightly different than what the formula we talked about.
I don't really know what you're asking.
So when we're figuring out, like, for example, just the size of A union B, that was the size of A plus the size of B minus the size of their intersection, right? Does that look familiar?
Katie said we could look at the intersections.
Do what?
Katie said we could look at the intersects.
The intersects. What
I
is
don't
it?
know why I said intersections, but
He just is putting out suggestions.
So we can also look at the intersects. Katie, can you go back and let me know what that means? What you mean?
Didn't we used them for like the different segments and stuff and rays, right?
That's right. Yes, we did.
Okay.
So we did. So like, for example, like going back to some of the stuff that we talked about, like let's make a smaller example. So say like A was 2, 4, 6. B is 1, 3, and 5. So here we would have a situation where we're looking at just essentially this. So if we look at the size of A union B, so if I make this little picture here, this is A, B. A is 2, 4, 6, 1, 3, 5. I don't put 1 here because that would mean 1 would also belong to A where the overlap is, right? So this would be the size of A plus the size of B. And if we go back to the original statement, minus n the size of A intersect B. Well, this is 3. That is 3. And then I subtract 0. So if I put these two guys together to make the set A union B, that's going to be the set 1, 2, 3, 4, 5, 6, which is 6. And if I count those, 1, 2, 3, 4, 5, 6, 6, they're the same. Now, if I went and changed the sets to look something like, so let's call C to be 1, 2, 3, 4. D be the set 2, 4, 6, 8. So if I look at C union D, I want to know what that is. So if I draw my little bubbles, C, D.
It would be 2 and 4, right?
So 1, and then 2 would go here. 3 goes out here. 4 would go here, like Emily said. And then 6, and then 8. So if I look at the union of the set, I have 1, 2, 3, 4, 6, 8. But if I did assume that the size of C union D is going to be the size of C plus just the size of D, that would be 4 plus 4, which is 8, but I only have 6. I double counted 2 and 4 by not counting out their intersect. So this should be 4 plus 4 minus 2 would be 8 minus 2, which is 6. But if we know they're mutually exclusive, that would mean that we wouldn't have to worry about subtracting out the double count. But when they have overlaps or dependencies on each other, then we have to worry about subtracting out that overlap. Does that make sense? Yeah, okay. So that's called, by the fancy word, the property of inclusion exclusion. And if their intersect is not empty, that means that they're not mutually exclusive, or they would share some events in the sample space. So if we go back to that example, we were looking at the card being an ace or a heart. That means that they were mutually exclusive, right? Or not. So if I look at the probability of us drawing an ace, what's the probability of drawing an ace?
4 out of 52.
452. Probability of drawing a heart.
So 12 out of 52.
13.
13 out of 52.
Okay.
Now, what's the probability of you getting a heart and an ace at the same time?
1 in 52.
So their intersection's not empty, which means I have to go to using this rule. So that would be the probability of picking an ace or a heart would be 4 out of 52 plus 13 out of 52 minus 1 out of 52. Because if I don't subtract out that 1 out of 52, I double counted the ace of hearts. So that's going to give me 16 out of 52, which is 4/13. Right?
Yeah.
Mhm.
Does that make sense to everybody?
The 1652, that's the probability for what?
Card is an ace or a heart.
Or a heart.
Oh, okay. Gotcha.
So that would mean in my Venn diagram, so I have the ace of hearts here. And then I have the ace of clubs, ace of diamonds, and then the ace of spades. And for the hearts, I would have ace of hearts, then the 2 of hearts, the 3 of hearts, the 4 of hearts, the 5 of hearts, the 6 of hearts, 7 of hearts, 8 of hearts, 9 of hearts, 10, jack, queen, and king. So if I looked at that, that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of those cards in this picture out of the 52 cards we could have had in total. Does that make sense? Now, if I was actually doing this in a class, like I would make a giant Venn diagram on the floor and actually have them put the cards in those Venn diagrams and actually have them actually place them where they want them to be. So you can make it a more kinetic and tactile learning idea and be more visual about it instead of them having to visualize in their head what that Venn diagram is actually showing them. Does that make sense? When you can actually concretely show them, and that's what we would have done if we were in class, is that I would have had a giant Venn diagram and I would have had the cards and we could tape them to the board and then actually place them in there. But we don't have that, so. Which is a bummer why we have class online instead of in face-to-face. A lot of things would be cooler if we were in the classroom. So, yeah. Now, complementary events. So if A describes the event happening that today is Tuesday, its complement would be today is not Tuesday. And two mutually exclusive events whose union is the sample space are complementary events, and they denote complements by using a bar notation. So not to get this confused, because we will also use the bar notation for averages. So this is something that gets kind of lost on some students, especially when they're trying to keep notation straight. You could also see it written as the complement of A can be written as a bar, or you can translate it to a with the little apostrophe at the top. But then that gets confusing for students who might see derivatives later on in calculus, but that's also a similar notation for that. So we only have so many symbols, so we have to know the context that we're using it in. Yeah. That's one of those things that mathematics has a hard time having a exact symbol that means exactly one thing. So if you happen to be Googling things, this might be something that you might come across. And of course, if I take the probability of the complement, it'll be 100% minus the probability that A happened. So if I added the probability of A plus the probability of its complement, I would get 100%. And then as a problem-solving strategy that we will see is that it will be sometimes easier to calculate the probability of the complement than it would be to calculate the actual probability of the thing that you're trying to find. And that's actually a very common strategy that I use in a class called probability theory and probabilistic methods, where all we did was find probabilities of these insane things happening, but we would find the complement and then subtract it from 1.
That sounds annoying. You would just do the same thing every day?
Well, there are different types of math problems to show that the existence of a solution was there. And the idea of complement, so there was a very off the wall kind of idea that because the proof that aliens do not exist is bigger than 0%, therefore there is a probability that they do exist.
So what's the probability that aliens exist?
It's it's greater than 0, but it's definitely less than 1. It's like, it might be like 0.0000001% chance. But because that probability is not 0, we can't say they don't exist. And there's actually like a big, long mathematical explanation for it. So
Ridiculous.
yeah. Yeah. It's one of those craziness things. And here are some common properties that would be useful in keeping close by. The probability of the empty set is 0, which means that it can't happen. The probability of the entire sample space, that means that it has to happen all the time, every time. For any event A, its probability is always between 0 and 1, cannot be less than 0, cannot be greater than 1. If we have mutually exclusive events, I can calculate the probability of A happening or B happening just by adding up the probabilities of each of them. But if they are not, then I have to subtract out where they overlap. And then, of course, there's a complement formula.
Wow, we've learned a lot today.
After wasting 10 minutes of watching.
Yeah, those are funny though.
I'm going to put together I will pick up here on Monday. I'm going to put together a small little quiz on some volume stuff. And I might make an extra quiz on probability stuff, on simple probability stuff. So you'll have
So
two
you're
quizzes.
gonna have 2 quizzes?
Yes, oh my God. Because
No,
the
that's
more,
okay. I'm
the
just
more
wondering.
more
Are you
quizzes mean more points. So.
Okay, and then you're gonna have those up what day?
Okay, so I'm working on those the rest of this afternoon and trying to get those videos up for y'all. So yeah, I'll be just pounding away and hope my internet does not crash on me.
Aren't you
Okay,
posting
so
the
I
test
should just
too?
like expect the quizzes on Sunday so then I remember to do them on Sunday.
I will send an email as soon as they are posted.
What about the test?
The test, I'm working on that too.
Okay.
So, and there will be an email on that too.
Is probability gonna be on it?
No, we're
Okay.
gonna stop with the volume.
Okay, cool.
So we have a week to complete the test from whenever you post it.
Yes.
Okay.
Cool.
Yeah, and then for the test on this other stuff, I will probably post that test early, and I probably will just start working on that and get that up there, and it won't be due until like the Monday probably before our last week of class. Does that make sense?
Mm-hmm.
And that way I have time to grade it and give it back to you, because you will have a final on that, and I will probably post the final shortly after that. And so that way y'all can just start knocking that stuff out.
Our 4th reflections due this weekend too.
Yes.
Just a reminder for everyone because I forgot.
And also, I know some of y'all are having a hard time getting things or getting the due dates because y'all thought y'all had until midnight the next day and not this day. If they're a day or two late, that's not a big deal. So yeah.
I hate online classes. I'm sorry.
No, it's really frustrating, yes, I understand.
I just get so flustered. I don't even know where to start.
I just have a hard time not getting a physical copy. So
Yeah.
like, I'm like, wait, what? And I just, because if I don't have something to hold on to, then I'm just like, it's not there. I don't know. It's
Yeah.
bad.
I'm so stressed out, bro.
I woke up in the
I'm
middle of
so-
the night about to do homework because I was so stressed. It was bad.